Well, hello. I must first of all apologise for missing my usual upload slots in the last 2 weeks. I've been quite unwell, you might hear that in my voice. I lost my voice, I've had a cough, I've had a cold, headaches, a whole lot. On the mend now, but not 100%. And I thought it was about time to get a video done. Now, another thing to excuse is there's kind of this array of clutter everywhere. It was all over the place, and just to get a bit of space to work, so I just pushed it all to one side. Hopefully none of these lithium polymer batteries are going to short out and we're going to have a fire again. But yeah, just forgive the mess basically. So one of the things I've knocked up in the last week or so is this kind of solar powered battery pack. I was going to cover that as a separate video, but I've not got around to doing that. Essentially, I've got a little UPS, a little battery pack there. I've actually cut a hole in the panel, installed that in. I've added a whole load of batteries in the back of this panel, and it's about, the panel is 5 volts at about 2.5 amps or something like that. So it'll charge this thing up 10-15 amp hour in a day, no problem. Now the next thing I wanted to do was add some fast charge ports. This thing will push 1 amp, this thing will push 2 amps. And actually when you plug it into Samsung devices and other fast charge supported devices, it doesn't really see these as fast charge. The voltage was a little bit low on these, about 4.8 volts. So it'll only pull about 700 milliamps out of either one of these ports. That could be this device itself is just not really capable of providing 2 amps, or it could be that the phone or whatever device it's plugged into is sensing that the voltage is low and throttling the current back. So one of the things I wanted to do was add adaptive fast charge to this. Now actually getting online and having a look for some sort of adaptive fast charger, ideally a car charger that's adaptive fast charging, is quite difficult to find. I haven't actually found one. I've managed to find wireless charge pads alright, but this isn't really suitable for installing a wireless charge pad. I don't think the wireless charge energy will go through a solar cell very well. I could try, but at this point I'm not going to try that. So what I've done is I've had a go at making a few different fast chargers myself. Let's pop this down this way, give us a surface to work on. So one of the things I've done is actually 3D printed these little holders and actually put my own little USB. Will that focus on there for me? Put my own little USB port in there, and then I thought I could put that in the side of the panel, and then I would be able to use something like one of these little step-up converters. Here's the step-up converter. The step-up converter set to 5 volts should be able to push 3 to 5 amps, I believe. Plug it into the phone there, and then the next thing I'm going to be using in this little experimentation, this rather nice little power meter I got. It's a little USB power meter, and what it will do is it will show us the amount of volts, the amount of power in milliamps that's going into the device, and also the total in watt hours as well, so you can kind of find the health of your battery in your phone using this thing. So we'll plug that in. I can plug that in and show that fire up. There it is. Now this thing is pushing about 5.10 volts out. And actually if I get something to plug it into, and I'm going to use my hated Galaxy S9. I really hate the thing. There's so many reasons why I hate it. It's just too big, it slides out my pocket, it's already cracked. It's just a bit poor really. Oh, it does all sorts of things you don't want it to do as well. So plug that in there. It's plugged into the 2 amp port. Turn this on and we can have a look at what's going on here. I'll zoom in if I can. So this nice little device, I think you can reset it. How do you reset it? There we go. So yeah, it says we're pushing 4.86 volts in at about 740 milliamps. And it will count up the total number of watt hours or milliamp hours that have gone in there. Quite nice. But the other nice feature of this is actually if the power is cut from the device, i.e. the battery runs out or your UPS shuts down, it will actually remember the last numbers on there. So when you next plug it in, you've still got that milliamp hour reading there until you reset it. So well worth it, this little device, for doing these kind of tests. So this device plugged into this solar panel, it's got a little battery pack motherboard in there, and it actually came from one of these, a smaller battery pack with a solar panel with a port in the end there, and I've actually cut that out and butchered it and fitted it in here, but cover that in more detail at another point. about 740 milliamps, not bad, but it is going to take some time to charge the phone. So I really want Samsung fast charge on this device. I've got a couple of other items that I may try and get a bit more power out of. Now I have been told and I've read that actually if you short the two data lines inside the socket, that tricks the phone into thinking it's a high powered AC adapter and it will actually go into a fast charge mode. I've tried that both on this port and the port on the cable direct. I've tried them both and neither of them seem to all of a sudden initiate it, even if you unplug it, plug it back in, turn it on and off, all sorts of things. Can't seem to initiate it taking any more than 740 milliamps direct off this panel. So, yeah, can't get it to do this anymore off this either. It's about 740 milliamps. And I've got a couple of other options that I've purchased now that claim that they support fast charge or that they can do high power charging. So I got this rather nice little 12 volt kind of screw in adapter here. It's kind of ideal for mounting in the dash of your car. It comes with a nice little rubber bung on it, costs a few quid. And what we're going to do here is actually put 12 volts into this. Let's connect this up. And this one over here. Got a nice little green LED. If you don't like the green LED, you can't really turn it off. All you can do is cover it up with that rubber bung, but the rubber bung is enough to stop all light coming out of there, so that annoys you. There doesn't seem to be any feature to disable that light or dim or increase it like you would on dash devices. So then we're going to plug this one in, and this one's got a lower voltage. It's 4.9 volts, so it's already below 5 volts. Plug it in. That the right way round, and this does actually push more in there. Let me just turn the screen off because the other one had the screen off. Yeah, it's a little lower with the screen off. It's 0.64 of an amp, so we're only able to push 640 milliamps off a port that's listed at 2.1 amp. It does go up occasionally. I noticed this S9 Plus seems to throttle the charge power up and down. And this is, yeah, it's pretty much the same as all the others. It seems to be its standard set charging current off a USB port is about 740 milliamps. And as mentioned, I can't seem to trick it into thinking it's an AC adapter for some reason. I'll try that one with one of my older phones later and see if I can do that. Okay, so this device, it seems to work. I don't know what the max power output is. I haven't plugged anything on there to do a load test on it. But it doesn't give us fast charge. You know, it's still going to take a couple of hours to charge this phone. Now, just out of curiosity and as a complete risk, I've actually used the adaptive fast charger that came with the phone. I plugged that in, read the voltage off here. I thought I'm at risk of blowing this thing up because I know that adaptive fast charge will actually push more than 5 volts into the device. So it kind of starts up at 5 volts. It somehow communicates or reads the resistor. I don't know what it does. I can't find that information out easily at the moment. But what it then does is ramps that voltage up to about 8 or 9 volts, and it was actually pushing at 8.8 volts at about 1.4 amps. So that will really charge that battery up pretty darn quick, really, especially if the battery is a 4.2 volt cell and not actually paired up into a 7 or 8 volt dual pack, or 2S as they call them. So yeah, that's really ideally what I want this thing to do, is be able to ramp it up to about 9 volts and charge it in there. So this isn't going to charge at high speed. The only way I can get a proper adaptive charge is to have this plugged into a 240 volt source somehow. So what's the next step? Well, I could put a little 240 volt inverter in here, have it boost from 5 volts, or actually 4.2 volts up to 12 volts, from 12 volts up to 240 AC, from 240 AC to the 9 or 5 volts that this puts out and power this adapter, which will then give me a fast charge port. That all just seems a bit long-winded, too many conversions, too many losses. I'm curious as to what the losses actually would be, but I have ordered some little inverters. I haven't got those at the moment, so I will do some loss checks in the future to see which is the most efficient method, but I can only guess that going from 4.2 volts up to 12, 250 back down to 5 is going to be pretty inefficient, and if we can get some of those steps out, we should improve the efficiency. This unit, I'd imagine it uses some sort of little switch mode converter. It doesn't get too hot even when you leave it charging. It's probably fairly efficient, and again I'll do some efficiency calculations on that at some point. Now the next thing I did find at a very good price is this little MOOBOM charger. It's a car charger, and it supports Qualcomm Quick Charge 2.0. Now Samsung's Quick Charge, I think, is called adaptive, what's it say? Adaptive fast charge. From what I understand, it may possibly be the Qualcomm Quick Charge, or they're certainly both compatible with each other. It is listed on the Samsung's website that a Qualcomm supporting device will enable fast charge. So this will be quite interesting. I got these things, they're about £2.50 or something. They're like way cheaper than some of the other chargers I got. I think this one was like £4 or £5. This one was £2.50. And they're quite nicely packaged up, aren't they? We've got a sleeve, we've got some more rubbish that we're going to have to throw away. Then we've got like additional rubbish, another piece of card. I got like a piece of foam, which looks like you could have a chess piece in there or something. More rubbish. Oh, a nice little CPE bag. That feels nice. Nice and soft. Okay, we'll tear it out of there. And we get all the way in, and you think if they've spent that much on all this packaging, this thing's going to be fairly good. And actually, looking at the build quality, it doesn't seem too bad. I was hoping I'd be able to get a crocodile clip on there, but I won't be able to get it on there. I have to solder straight to it in a minute. Yeah, that doesn't seem bad. And it's also come with a lead. Is this lead any good? You can usually tell pretty quick. It feels pretty hefty actually, and it's about a metre. Not a long lead, but it is coloured as if it's USB 3, so we'd hope that this one is going to support the fast charge. So I think I'll use this one. No, I'm going to stick with the Samsung original. Maybe we'll compare it to this afterwards. So Samsung original into our power meter. Get rid of all the rubbish. So much rubbish. That's all right. And yeah, we'll connect this in. And then I need to somehow put 12 volts on here and see what's happening. So let's bring my crocky in, and then we'll just kind of somehow hold all this together. Should have a little cigar adapter socket somewhere, but I don't know where it is right now. Okay, and then let's just clip this one on, and it's lit up. It's lit up blue, and straight away it says it's fast charging, and it will take 1 hour to fast charge. And if we look down here, we're getting 1 amp at 5 volts, and now we're up to 8.7 volts at 1.5 amps. And actually, if I were to look at the power supply, we're putting 11.5 volts in at 1.1 amp, and we're getting 8.7 volts at 1.4 amps. Pretty damn good. I don't know if you can see that there. Oh, it's all undone now, but we'll watch that trigger off into adaptive fast charge. It does say it supports adaptive fast charge on 2 ports on there, so that's quite interesting. Okay, you can see it starts off at 5 volts at about 1.2 amps, still at about 5 volts, and then after it's done some kind of, I don't know what it's doing, it boosts up to 8.6, 8.7 volts at about 1.5 amps. Perfect, just what we needed. I'm actually going to do a little efficiency rating on this one, just try and figure that out. We've got how many volts there, we've got how many amps. better get a bit of paper and write this down. Okay, so I'm just going to do the test here. I'm going to round this voltage up to exactly 12 volts so it's easier to work with. And I'm going to connect this up. And I'm going to let it settle down to 9 volts before I try and take a power rating off it. Will you clip on there for me or not? It's all a bit much. Should really have a socket for this. Clip on, powered up. So it's warming up, and you're going to go into 9 volt mode. We're in 9 volt mode. So once we're charging at full rate, can I keep this on? We're getting 12 volts at, lower now, 1.05 amps, that's in, and out we're getting, oh I've lost it now, out we're getting 8.7 volts at 1.3, we're going to go low, 1.37 amps, okay, so that's about what's going on there, and I'll work them out into watts now. I'm going to use a calculator for that. So going in, we have about 12.6 watts, and coming out we have 8.7 times 1.37 equals 11.91 watts. That's pretty damn efficient, really. We're only losing you know, just under 1 watt. Yeah, it's really good. It's really good. Not bad at all for something converting that voltage. I guess there's not much conversion needed there, but it is a little switch mode supply drawing at 1.3 amps. Quite nice. Right, let's go in for this other unit here. Clip that on, or clip that on, plug the charger in. Where is the charger? And then I'll just give it a moment or two to settle. So here we have going in 12 volts at 333 milliamps, so much lower, and out we have 4.79 volts at 640 milliamps. So let's have a look at this one in loss wise. So 12 0.33 is in 3.99 watts, and out is going to be, and out is 3.06 watts. So we've lost closer to a watt here, whereas we've lost closer to 0.7 of a watt here. So efficiency wise, you know, fraction of a difference, but in charge rate we're almost, well, that's we're almost 3 times faster charge rate with this device here, yet the same efficiency, or very well, slightly better efficiency even. So yeah, I think that's the way to go for fast charging. We're going to be using one of these MOOBOM charge. I'm going to try that out for a while, do a few charges on it before I hack it apart and have a go at charging something else with it.